Hi, in this lab we're going to be looking at how to use Minitab in order to randomly generate or simulate situations. So we're going to have Minitab randomly generate numbers in order to simulate different experiments. So this just saves a bunch of time. If you could imagine rolling a pair of dice 1,000 times, it's a lot faster to just have Minitab create that process for you, and we can do those sorts of things using Minitab. So that's the first example that I wanted to talk about. You need to be careful about how you have Minitab randomly generate your numbers. So in this example, what we're doing is rolling 2 die, and then we add up the numbers that are facing up. So that's what we want to simulate. So the correct way to simulate that is to have Minitab randomly generate integers from 1 to 6, including 1 and 6, and then have it randomly generate another number between 1 and 6, including 1 and 6, and then add the two numbers together. The wrong way to go about doing this would be to have Minitab randomly generate numbers between 2 and 12. So you'll get totally different results if you do it in the two different ways. So we want to make sure that we're careful in how we have it generate our numbers. And we could probably even run through that just to show you that you do end up getting different results. So in order to have Minitab generate or random numbers or to do simulations, it's pretty easy. You just click on the Calc menu along the top, and then you'll select Random Data, and it will bring up a whole long list of options for you. The 4 that we'll be looking at are integer, uniform, Bernoulli, and normal, and we'll talk more about what each of those are as we go through the examples. So the first one is an integer. So this generates a sample of randomly selected integers with a specified minimum and maximum. You will need to specify 4 things for this. The number of rows of data that you want it to generate, so that's how many numbers you want. What column you want to put the numbers in. You'll need to give it a minimum value and a maximum value. So if you would like to simulate 100 rolls of a die, you would enter 100 for the number of rows of data to generate. Tell it where you want the data, for example C1, give it a minimum value of 1 and a maximum value of 6. So let's just go into Minitab and we'll do that. So we want to go to Calc, and on the bottom, random data, and then we want integer. And then we'll fill in this box. So we want the number of rows of data to generate, and so that was 100. And then we need to tell it where to store the data. So we can store it in C1. And we want a minimum, so that was 1. And then we want a maximum, and that was 6. And then we can just go ahead and click OK. And here we can see that Minitab has generated 100 data values for us that are all between 1 and 6. So that was much quicker than rolling a die 100 times and writing down what the number was that came up. So let's go ahead and have Minitab do this again. So Calc, random data, and integer again. And we're just going to keep all of this the same, except for I'm going to have it store the data in column C2 this time. Click on OK, and now I have pairs. So we were talking about this before. And now I'm going to have Minitab add these up. So that's a lot faster to just have Minitab do it. And I'm going to put that in C3. So you can go into Calc and then click on the calculator. And we want to store the results in C3. And then the expression that we want is we want the sum of C1 and C2. So there are all of these functions that you can use. And there is probably a sum function. Yep, it's hard to do it with my, so you can sum rows, you can sum things, but we could just type it in too. So we could click on that, press select, and then you have operations here that you can do. So plus, and then select C2. And then we can just hit OK. And so now column C3 is the sum of column C1 and C2. So that's the sum of our dice. And now in column C4, I'm going to have Minitab generate random numbers that are between 2 and 12. And we'll do 100 of them. And this time I want to store the data in C4. I want 100 of them, so everything else is okay. 100 of them, 1 to 6. Oops. Sorry, I wanted 2 to 12 this time. So we'll just ignore column C4, and we'll put the data in column C5, the correct way this time. So again, don't be afraid of, making a mistake. It doesn't hurt anything. So click on integers. So now I want C5 this time, because I goofed up on the first time. And we really want a minimum of 2. And we want a maximum of 12. Whoops, somehow that didn't erase my number. And a maximum this time of 12. Just so that we can see the difference between doing this simulation the correct way and the wrong way. And so now we can take a look at histograms. So go up to graph, and we want to create a histogram. And we want just a simple histogram. Click on OK. Oops, we want C3 the sum. And we also want to do C5. And we want multiple graphs, and we want them in separate panels of the same graph. And use the same X scale and Y scale. Click on OK, and click on OK again. And here we can see column C3 and C5 displayed together. And you can see that these are very different histograms, and so the data behaves very differently if you do the simulation one way versus another. So, so just wanted to show you that as well as we're going through things. The next thing is the uniform distribution. So I'm just going to go back to the instructions here. So uniform distribution will generate generate numbers that are decimal numbers. So if you want whole numbers, 1, 2, 3, 4, 5, you should be using integer. And you use uniform if you want decimal numbers. So it works very similar. And you go click on Calc, Random Data, and Uniform. And so we want the number of rows. So you would type in however many uniform numbers you want, where you want it to store these. And so you can do, so let's do 20. And you can actually choose to store these in several columns. So we could have done both the dice at the same time if we wanted to, because we could specify more than one column. So I'll show you that quickly. So we could do C1. Oh, we've already used C1 through C5, so we'll do C6. And then we could do through, whoops, that's the wrong symbol. through C8. So we'll do a couple of rows of data and then use a lower endpoint and an upper endpoint. And so this would generate numbers between 0 and 1 that are decimal numbers. Then we can click on OK, and we can see that I generated decimal numbers between 0 and 1, and I generated 3 rows. So one of your lab problems is going to have you generate 2 sets of numbers between 0 and 1, and so that you could just do this only with 2 rows instead of 3 like I did here. And then we want Bernoulli, so I'll just go back to the instructions. So Bernoulli you want to use for things where there's only 2 different options, boy, girl, yes, no, things like that is where you would want to use the Bernoulli. So this will generate zeros and ones. Zeros are considered failures, ones are considered successes, and here it will, the default is that the probability of a failure is 0.5 and the probability of a success is 0.5. You will have to tell it how many rows of data to generate, just like with all the other ones. You'll need to tell it where to store your data, and you will need to tell it the probability of an event. So that means the probability of a success or the probability of a 1 occurring. Next is the normal distribution. So click on Calc, Random Data, and then select Normal. So the normal distribution, remember, is a bell-shaped curve. The things that you will have to enter in are the number of rows or the number of data you want generated, where you want it to store your data, what the mean is, and what the standard deviation is. So you'll need to enter that information in as well. And then how to sort data. So sometimes it's important to sort data. You would click on Data, Sort, select the column that contains the data you would like to sort, and then in the box by column, enter the column that contains the data you want to sort. So for example, C1, and we'll sort one of the columns in our table. So why don't we do that now? So go click on Data, oops, and Sort. And they've changed the look of this slightly since I created the lab instructions. So let's sort column C1. So you have to click over here, and then you can click on C1 and select it, or you can double click it, but I'm using a pen so it's easier to do it by clicking on Select. And then columns to sort is specified column, and we just want C1. And then put this at the end of the worksheet is fine as well. So then click on OK, and so now it has sorted column C1 in C9 there. And so we can see that it has this sorted. So another thing about sorting, a lot of times when you're sorting you want to count, and it's going to be hard for me to do with my pen, but I will try, is that in the Minitab, if you, let me see if it'll even let me do it here. So see, if I drag, it tells me in the yellow box how many rows I have selected and how many columns I have selected. So if I want to know how many ones I have, you could just drag over all of them and go, oh, well, I have 15 ones. As soon as you let go, it's gone. But it's an easier way to count than going 1, 2, 3, 4, I think. And so here I have 17 twos. And then I could do the same thing for the threes, is we could drag over them. So if you need to count a bunch of things in Minitab, that's one way to do it. Another way would be to create a histogram. And so I can go ahead and quickly create a histogram, and I'll show you how to do that as well. And so here I am going to just choose C1 and click on OK. And so here, if you just hover over or click on a bar, it will tell you how high the bar is. And so I have 15 ones, I have 17 twos, there are 15 threes, there are 21 fours. So that's another easy way to count data in Minitab, is to do it with a histogram. So just a couple of ways for you to do things there. Okay, now we're going to go ahead and just take a look at the lab and talk about a few things in the lab that you need to do this week. So the first one should be okay. So you need to generate 800 IQ scores, and it gives you the mean of 100 and the standard deviation of 15. So go ahead and do that and answer those questions. If you have questions about it, let me know. And then the next one, you want to simulate a class with 25 birth dates. So we want just to generate 25 integers between 1 and 365. And then you're going to want to look at all of the numbers that you generate, those 25 integers that are between 1 and 365, and then just see if any of them are the same. So do you have more than 1 3 or more than 1 7 or whatever? Do any of the numbers in that column repeat? And so you want to do this 10 times, so you're really going to actually fill columns C1 through C10 with 25 integers that are between 1 and 365. And then here, put a yes if there's a matching birthday and a no if there's not a matching birthday. So again, you're going to look at your column C1. If there is a matching number, the easiest way to see if there are matching numbers would be to sort the data, because then the matching numbers will be right next to each other. So in number 3, you want to simulate a baseball World Series. So I wanted to talk about this one specifically because I know that there are people out there that don't follow baseball and that don't know how the World Series works. So the World Series lasts at least 4 games, but could potentially go up to 7 games. So there are 2 leagues in baseball, the American League and the National League. And so at the end of the season, 1 team from each of those leagues goes to the World Series. And the first team to win 4 games is the winner of the World Series. The American League, the team for the American League that goes, could win the first 4 games and then the World Series would be over. But the American League could win a game, and then the National League could win, and then the American League, so they can go back and forth. But if there are 7 games, somebody's going to win 4 of them. One team's going to win 4, and the other team will have to win 3. So again, it's a little bit complicated if you don't follow sports very much, but the first team to win 4 games is going to be the winner of the series. So you need to simulate this, and you do it with integers. You're going to let 0 be the American League winning a game, and a 1 is going to mean that the National League has won the game. And so what you need to do then is use the integer generator, and we want to simulate 20 of these. So you need 20 rows of data in columns C1 through C7. From the integer function, minimum of 0, oh, sorry, not integer, we want Bernoulli for this one. And then answer all of these questions. So how many series did the National League win? How many series did the American League win? How many series lasted only 4 games? How many series lasted 5 games, 6 games, and 7 games? And then you want to repeat this, but now you're going to change the probability of a success to 0.6. So I'm only going to do 1 row of data to show you how this works. So I'm going to close this so that I don't have anything else in here. So we want to random data, and this time we want Bernoulli. And number of rows of data, I'll do a couple rows, I guess. And then where do I want to store the data? You want to store the data in columns C1 through C7. And the event probability, we want that to be 0.5. And then click on OK. So now I have 7 rows, so each row is going to be a World Series. So this row is a World Series, and then row 2 is a World Series, and then row 3 is a World Series. So the easiest way to tell who won that World Series or who didn't win is to add up all of these columns. So in C8, I'm going to do the sum of each of my columns. And I need to store the results in C8. And then click on OK. So, because these are all zeros and ones, if the sum is 4 or larger, that means that there are 4 or more ones in that row, which tells us that the National League has won the World Series because they have 4 out of the 7 games that they've won. If the sum is less than 4, then we know that the American League has won because there are at least 4 zeros, if not more than 4 zeros. So in my World Series, I did 3 World Series here, rows 1, 2, and 3. And the first World Series was won by the National League because it's a 4. That means that there are 4 ones in that row. So then for the rest of the questions, now how many series lasted? Only 4 games. So let's go back to my results. So here's where it gets a little bit harder, is because we need to figure out how many series lasted only 4 games. So looking at this first row, so you can see that it was alternating back and forth, right? So the American League won the first game, and then the National League, and then the American, and then the National, and then the National, and then the American, and then the National. So this one lasted 7 games, right? Because it is not over until a team wins 4 games. And the National League didn't win their 4th game until the last game, the 7th game. So let's take a look at the second World Series in my simulation. So we had the American League won the first 3 games, and then the National League won a game. And now in Game 5, the American League won again. And so this World Series really stops right here at Game 5 because the American League has won 4 games now. So that ended in the 5th game. My first World Series ended in the 7th. My second World Series ended in the 5th. And then the last one is the same as the second, basically. So we have American, American, National, American, American. So this one also ended in the 5th game. So in my questions, I would say the National League won 1 World Series, the American League won 2. There weren't any games that were over after the 4th game. There were 2 games that were done after the 5th game, 0 games after the 6th, 1 lasted all 7 games. And then you want to do this again, only now you want to change that probability from 0.5 like it was the first time to 0.6, and then compare your results. So one thing that you can do when you're completing your lab is write in the results for your first attempt. You could do over on one side and do the second on the other side. Just make sure that you label, like this is the 0.5 and this is the 0.6 data. So again, this is a little bit complicated. If you have any questions about this at all, just let me know and we can get that straightened out. And then the last problem that you have to do is using the uniform distribution. So I've got an example here for you in your lab, so make sure that you read through that. This is the one we're going to have, you're going to generate 10 rows that has 2 columns, so that's in the instructions, and each of those is going to represent places where you're breaking a stick that's 1 unit long. You can form a triangle with these if all of your line segments, or if there's no line segment that's longer than 0.5. So a triangle can be formed if the longest segment is less than 0.5. So if any of your segments end up being bigger than a half, then you can't form a triangle. And so you're going to get 2 numbers, 1 in each column of data, and you want to write the smaller number down first and then the bigger number down second, and then here's how you would compute your lengths. So the length of the first piece is, for this example, is 0.2841. And here, to calculate the length of this one, you would take this, whatever number you get here, your bigger number, minus your smaller number. Gives you the length of the middle segment. And then the length of this segment is going to be 1 minus this number. So again, there's an example right here, all done for you. So here are the lengths of my line segments, and I have one that's bigger than 0.5, and so I cannot form a triangle. Okay, so you're going to go ahead and do that. You're going to do it 10 times in total. One time you're going to fill in information here, and then for the other 9 times you'll fill in your information in this table. And then based on the 10 trials, what's the estimated probability that a triangle can be made? So again, remember, that's the total number of yeses you got divided by however many times you did it. So you'd be dividing by 10 in that case. That is all for this lab. Let me know if you have any questions, and I hope you have a great day. Thanks.